I'm Luisa.
And I'm Denise.
And I'm Samara.
And today we're going to be talking about Chapter 6,
the skeletal system
and bone tissue.
Enjoy!
So we're going to talk about some general information on bones. Bones are avascular, means they have no blood supplies and they have no nerves. They're surrounded by the perichondrium. They grow for appositional and interstitional. Appositional, the forming cells in the surrounding perichondrium, they grow out. And interstitional, the little cane-bound chondrocytes, they grow within.
Next, we're going to talk about the three types of cartilage. First, we have hyaline cartilage that looks like frosted glass when freshly exposed. It is the most abundant skeletal cartilage. It includes articular cartilage, which are joints, points of connection, which covers ends of most bones at movable points. It is located in the larynx, the breastbone, and external nose. Second, we have elastic cartilage, which resembles hyaline cartilage. However, it contains more stretchy elastic fibers, able to stand up against repeated bending. It is located in the epiglottis and external ear. Lastly, we have fibrocartilage, highly compressible with tensile strength, consists of roughly parallel rows of chondrocytes. It is located in the meniscus of the knee and in between the vertebrae.
Next, we have the 5 functions of the skeletal system. 1, supports. So bones provide frameworks that support our body and cradles our soft organs. 2, protection. It protects our internal organs. 3, movement. So bones are anchor points for muscles. Bones are levers to move the body in its parts. 4, mineral storage. So it stores and releases minerals and fats. So bones are reservoirs for minerals and most importantly, calcium and phosphate. And 5, blood cell formation, which produce blood cells. Bone structure. So compact versus spongy bone. Compact bone looks smooth and solid and is the dense outer layer. Spongy bone has a mesh of bony spine called trabeculae. Trabeculae are filled with red and yellow bone marrow.
Now we're going to talk about structure of short, irregular, and flat bones. Short bones are roughly cube-shaped. An example of a short bone is the wrist and the ankle. The sesamoid bone are a special type of short bone that forms in the tendon like a patella. They reduce friction and modify pressure to tendons to reduce abrasion or tearing. Now we have a flat bone. Flat bones are thin and flat and are curved. Example of that is the sternum, scapula, and cranial bones. Lastly, we have irregular bones that have a complicated shape that do not fit any of the other classes. Example, hip bone and vertebrae. Let me read that. Short irregular bones have a simple pattern. They all consist of thin plates of spongy bone and called the diplo, covered by compact bone. These bones are not cylindrical and therefore they have no shaft or extended ends. They contain bone marrow between trabeculae. Next, we're going to talk about bone formation. First step is an ossification center appears in the fibrous connective tissue membrane. Step 2 is bone matrix, osteoid, is secreted within the fibrous membrane and new bone is being formed. Step 3, spongy bone and periosteum forms, which means the blood vessels will start to be seen. Step 4, contact bone is starting to form and red bone marrow will start to appear.
Next, we're going to be talking about membranes. Let's begin with the periosteum, which is a thin double layer of dense, irregular, connective tissue which covers bones. Then there's the outer layer is fibrous. The inner layer is osteogenic. It contains osteoblasts, which makes the bone matrix, and osteoclasts, which dissolve the bone matrix. Nutrient foramina are bone openings that many nerve fibers and blood vessels go through from the shaft. Sharpie fibers secrete the bone matrix. It also has a medullary cavity which contains marrow. Lastly, there's the endosteum. It covers internal bone surfaces, it lines medullary cavity, and has osteoblasts and osteoclasts.
Stages of the chondrial ossification. Stage 1, bone collar forms around the diaphysis in the Hyaline cartilage model. Stage 2, cartilage calcifies in the center of the diaphysis and then develops cavity. Stage 3, the periosteal bud invades the internal cavity and spongy bone is formed. Stage 4, the diaphysis elongates and a mandibular cavity forms. Secondary ossification center appears in the epiphysis. The epiphysis ossifies, then ossification is complete. Hyaline cartilage remains only in the epiphyseal plate in articular cartilage. Okay, bone process, bone resorption. During resorption, bones cell.
Next, we're going to talk about bone growth. Proliferation zone. These cells are divided quickly, pushing the epiphyses and far away from the diaphyses, lengthening the entire long bone. Next, we have hypertonic zone. The lacunae erodes and enlarges, leaving large interconnecting spaces. 3 is a calcification zone. The surrounding cartilage matrix begins to erode, allowing blood vessels to invade. Lastly, we have an ossification zone. The calcified spicules are invaded by marrow, eliminates from in the medullary cavity. Next, we're going to talk about bone remodeling. Bone resorption is osteoclasts moving along the bone surface, digging depressions or grooves as they break down the bone matrix. Next, we have bone deposition. It's the process of crystallization in which calcium phosphate and other ions are taken from the blood plasma and deposited in the bone tissue, mainly as needle-like crystals of the hydroplate. Next, we have hormonal control. Without normal levels of blood calcium, nerves cannot fire as needed, and muscles are unable to contract. Hormones use a vast amount of calcium in bone as a storage bank from which they can withdraw or deposit as needed to maintain extracellular fluid calcium levels. Lastly, we have mechanical stress. It is how the body responds to muscle pull and gravity. Wolff's Law holds that bones grow or remodel in response to demands placed on it. For example, curved bones are thicker where they are most likely to buckle. And lastly, the trabecula of spongy bone form trusses along lines of compression. Next, we're going to talk about fracture repair. First, a hematoma forms, which means the blood vessels in the bone and the periosteum are torn. The hemorrhage blood clots. Soon, bone cells deprived of nutrients will die, and the tissue at the site becomes swollen, painful, and inflamed. Second, we have fibrocartilage callus. Formed so within a few days, new blood vessels will grow into the clots. The fibroblasts produce collagen fibers that span the break and connect the broken bone ends. The chondroblasts secrete a cartilaginous matrix that bulges externally, then calcifies. Third, bony callus forms within this mass of repair tissue.
Osteoblast begins forming spongy bone. Within a week, osteoblasts begin to lay down the trabecula of the new bone around and within the fibrocartilage callus. The trabecula then spans the width of the callus and unites the two fragments of the bone. This process generally repeats the event of endochondral ossification. Bone remodeling occurs. The excess material on the diaphyses exterior and within the medullary cavity is removed. Compact bone is laid down to restore the shaft walls. The repaired bone looks like the original bone because it responds to the same set of mechanical stressors.
Next, we're going to discuss the microscopic structure of a compact bone. The compact bone consists of the habergeon. The habergeons are osteons, which is the structural unit of a bone. Habergeon central canal runs through the core of an osteon. Lucinae are small cavities that contain osteocytes. Canaliculi are hair-like canals that connect lucinae to each other and to central canal. Concentric layers of osteons are called lamellae. Pepperoni discs are canals called Boltzmann's canal, lying in the stem that occur at the right angles to the central canal. They connect blood vessels and nerves of the periosteum, medullary cavity, and central cavity. Circumferential lamellae are layers of bone mixtures that go all the way around the bone. Institutional lamellae are the space between osteons. Chemical composition of bone. Bone is made up of organic and inorganic components. The organic components include osteogenic cells, osteoblasts, osteocytes, bone lining cells, osteoclasts, and osteoid. It consists of ground substance, collagen fibers, which contribute to height and cell strength and flexibility of bone. Inorganic components, hydropathies, include mineral salts. They make up 65% of bone mass. They consist mainly of calcium fibers, consist of tiny calcium phosphate crystal in the ground collagen fibers, responsible for hardness and resistance to compression, lasts long after death because of mineral composition.